cameras have typically been a frame at a time, but that's not necessarily the best way to do things. Can you tell us a little bit about the technology that you have that is working much different?
Yes. So at Prophecy, we have developed a new type of sensing technology that is inspired by the way the human eye works. So rather than capturing images at fixed point in time, like the camera that is currently recording this video, our sensor, like the human eye, is only capturing changes in the scene, only what is moving. When you look at me at this moment, your eyes are not sending a full image to the brain, but only what is changing. For instance, my hands that are moving, or my eyes that are blinking. But for instance, the background, which is static, is not being captured by our eyes over and over in order to avoid that the brain is offloaded with useless information. So the eyes, the retina, does this fantastic job of pre-processing data and only sending to the brain what is useful to take a decision. So at Prophecy, we have developed exactly the same principle, a vision sensor that emulates the way the biological retina works, capturing only changes in the scene by having pixels that are fully independent and asynchronous. And instead of having a fixed frame rate with fixed exposure time, our pixels are capturing independently only what is changes in the scene.
Okay. Now, how does that differ in terms of performance? Can you get the same kind of resolution? Is it going to be color or is it going to be black and white?
Yeah. So compared to a regular frame-based sensor, essentially our sensor is also built using conventional CMOS processes, which means that we are designing our array with a matrix of pixels. So in terms of resolution, can be the equivalent resolution of a regular frame-based sensor. At the moment, we have a QVGA, VGA, and HD sensor, but nothing prevents the technology to go to higher or lower resolution. The difference is that our sensor is at the moment capturing only changes in the scene, and the change is a light contrast change compared to a certain sensitivity threshold that can be set according to the application. So the outcome is a stream of event data that carry this information about a relative increase or decrease of light. So there is no intensity value. So to your question, there is no, for instance, color information, but there is a very high time precise information of when these change happen and where in the scene it has happened. So in this demo, we're actually showing the sensor capturing the motion of my hand, and we are actually applying on top of the event data also some processing, in this case the optical flow. So the arrows you see displayed together with the event are showing the direction and the intensity of the motion of my hand, so the so-called optical flow. What you can appreciate here is the sparsity of the data, so there are no activity if there is no motion, and then as soon as I'm shaking my hands, you can see the activities displayed, and on top of it with this optical flow that is dense and calculated in real time with high precision. In this demo, we're actually putting our sensor inside this smart glasses, and we are tracking the position of the eye. And with this orange dot, we can see where we are looking at with very high speed and precision.
For example, currently, I just finished the calibration, so we can take a look of my hands. And for example, if I focus on my middle finger and or little finger, thumb finger, then if we also look at something with distance, I'm looking at the Prophecy's logo, and you can see the orange point is always can be appeared at the correct position.
So in this demo, we are using our sensor integrated in a lucid camera, looking at this flow of particles that are rotating in this object. And we are also applying some algorithm to detect, identify, and track this particle at very high speed, as you can see in the display. So different bounding boxes with different color, different size, that are detecting and tracking different type of bubbles spinning around. So in this demo, we are using our GX320 integrated in an OpenMV camera that will be released soon. So we are modulating LED at 120 hertz. And we are tuning actually the sensor to be able to detect high frequency, but not low frequency of changes. In fact, you can see actually that if I move the LED, the camera is detecting and tracking at very high speed. And if in the background I move my hand, you cannot see it, right? Because the frequency of changes is much lower than the LED. So this can be useful for certain application where you are interested to track only high frequency changes, like application in constellation tracking for virtual reality gaming.
Well, some of the applications that this works with are kind of interesting because you have certain advantages. For example, gesture recognition, head tracking, things of that nature. Can you talk about those?
Yes, absolutely. So here at CS, we are trying to put more emphasis on this fast emerging market around XR smart glasses, where human-machine interfaces are key to enable this device to offer to users a type of immersive experience and to be immersed in this augmented or virtual reality. Of course, you need to interact with either some gesture or with your eyes, for instance, to point in the scene what you want to look at or what you want to interact with. So when you think about this type of human-machine interface, then you need a sensor input that capture this information in a way that is fast enough to make the experience immersive, to make the experience natural. You want to avoid some effect of lag that can be quite annoying. Second, because these are consumer devices primarily, OEMs or ODMs are trying to optimize their design to make it battery power or to make sure that the battery lasts as long as possible. So power consumption is a key concern. And this is where conventional frame-based technology are posing some challenges, because on one side you want to have a fast immersive experience which require a certain type of frame rate, sometimes a high frame rate, while at the same time reducing power as much as possible. And this equation is today posing many compromises with conventional frame-based technology that we are addressing and solving with an event-based sensor, because our sensor on one side capture only changes, but at very high speed, which solve the problem of power consumption on one side while delivering a natural, fast, immersive experience.